We're going to attempt time travel. We are computing our trajectory at this time.
Well, the way we experience time is though it's just something right here, and there's no past and no future. The present is just always here. That's how humans experience time.
But because every once in a while we see something repeat, sun comes up, it goes down, it comes up again, we can compare that which is repeating with the things which are constantly chaotically going on, and that gives us a notion of, well, how do these compare? From that comparison, we infer time.
There's a psychological arrow of time which has to do with our consciousness, and that is our feeling that time is moving on. We age, we're born, we die, you know, the common sense idea of time.
But physics describes time differently, as just another dimension. So, like time, like just as Moscow is there while you're not there, so is the past there while you're not there, in the physics description.
In Einstein's theory of relativity, time does have a pretty precise technical meaning, enough for us to talk about time travel, for example.
Mr. Decker.
Emergency alert.
Wormhole. Get us back on impulse power. Full reverse.
The physics description is extremely successful at explaining many, many exotic phenomena, while our notion of the present just being right here is useful for everyday life, but it doesn't explain things like black holes and quantum tunneling.
Black holes are when a star has exhausted its fuel and collapses under its own weight. And so the black hole is a kind of a wormhole. The problem with a black hole is that you can't use it to travel through. If you go into a black hole, you're going to be crushed out of existence and meet your death. And so what you want is a kind of benign black hole which doesn't crush you when you go into it, and that's what the Stargate wormhole is about. And what happens is with the wormhole, there's an alternate connection. Literally, think of a wormhole in an apple. It's an alternate route to get from point A to point B. So the wormhole is often the fast way to get there. It's just that the distance through that you have to travel through the wormhole is shorter than the distance outside the wormhole. So that's the basic idea of it. A wormhole, now this is a standard idea today. This is not a far-out idea. The idea was basically developed by Kip Thorne, who is the Richard Feynman Professor of Physics and Astrophysics at California Institute of Technology, which is probably the top physics school today in the world. And what happened was Carl Sagan, in the mid-'80s, was writing his science fiction novel, Contact. So Carl Sagan, who was a professor of biology, exobiology at Cornell, my alma mater, actually, called up Kip and said, look, Kip, I want to try to make this story as accurate as possible. Now, can we actually build a Stargate? A wormhole is kind of like a Stargate. It enables you to get from one part of the universe to a distant part of the universe basically instantly, and perhaps even travel into the future and into the past. Kip Thorne started thinking, well, is it really possible to do this? Yes, you can do it within Einstein's theory of gravity. That's what all physicists use today, is what's called general relativity. It's also called geometrodynamics, in which the fabric of reality is space-time itself. Space is unified with time. It forms a kind of like, almost like a fabric, if you want. And the fabric can be crumpled or bent, folded. The clincher, the problem with all this, is that to make a Stargate, or wormhole, we call it traversable wormhole, Stargate, means the same thing. You need a special kind of what they thought was matter. You need what's called exotic matter. Okay, and nobody really knows how to make this stuff until maybe recently. That's what my theory's about. That I may have stumbled into a way to make the exotic matter that Kip Thorne needs to plug into his equations of Einstein to make the Stargate actually work.
All these concepts about wormholes and parallel universes, they actually fit into what I call, or what has been known as quantum physics. Because in relativity theory, we had the idea that wormholes could connect alternate realities, alternate universes. In quantum physics, we have the idea that these alternate universes all come into being at once, simply by the act of an observation of any observing conscious being. And suddenly all the possible outcomes that could possibly occur pop in all at the same time.
What quantum theory does is makes the observer all important. That the world is different depending on whether you're looking at the world or not. That's the essence of quantum theory.
Mr. Scott.
Aye, sir.
We'll be going to warp speed.
Aye, sir.
Course plotted for regular 1A.
Engage warp engines.
Let's say you can't really travel faster than light, but you can practically, for all practical purposes, you can travel faster than light. And the way you do that is to find a way to go close to the speed of light, maybe 99% of the speed of light. And then Einstein's laws will guarantee that you are now, for practical purposes, though not really, traveling faster than light. And this is the way that works. If you go faster and faster, your clocks slow down. This is one of the first laws of special relativity. The faster you go, the faster your clocks slow down. The slower you age, everything slows down to a crawl. That's inside the ship. Looking outside, links shrink to the same ratio. There's something called the gamma ratio. That gamma ratio may be 1 in 1,000. If you're going very close to the speed of light, it might be 1,000 to 1. So your clocks slow down by a factor of 1,000, and links shrink by 1,000. So you can go, because your clocks, because you're slowing down, you can cross the universe in a second by subjective time, but it takes you 1,000 years by objective time measured on the outside. So to you inside, you've traveled much, much faster than light. Well, everyone outside says, no, they didn't. They took 1,000 years. But, and it's true for them, the outsiders, you did take 1,000 years, but for the insiders on the ship, you took 1 second. So when you get out there, you've traveled 1,000 times the speed of light. But when you get back, no one's there on Earth because 1,000 years have passed and all your friends have died. You have returned to an Earth 1,000 years in the future. You have traveled to the future, a future that ordinarily you would not have access to. You would have died in 100 years. So you can travel, even with modest improvements in our technology. They could put you in a spinning centrifuge that traveled a fraction of the speed of light, and you will age very slowly. Get out of that centrifuge, you'll be 1,000 years in the future. It's kind of a Rip Van Winkle machine. That's possible with modest increases in our technology to travel to the future and wake up 1,000 years from now, as long as they kept the machine running.
On Vulcan, I began sensing a consciousness from a source more powerful than I have ever encountered. Thought patterns of exactingly perfect order.
Could we build a device, a kind of a machine, a quantum machine, that maybe if we could hook it up and design it properly, would enable us to time travel in some way? If we could, how would it do that? And what kind of machine would this have to be? There's something called quantum computers. These are computers in which the elements of the computer work by the laws of quantum physics directly observable by the user of this computer. Quantum computers, ordinary computers, do operate by the laws of quantum physics, but we don't have access to that. All we're interested in is that bit better be a 0 or it better be a 1. I don't want any maybes. Quantum computers is a world of infinite maybes, which pop into 0s or 1s depending on how we tend to observe them. If we could build such a thing called a quantum computer, it would be possible then, I think, to use it as a kind of an amplifier in which we might be able to actually affect the past. Possibly we might amplify our thoughts in such a way that the past, which we remember, might be flipped or transformed or changed in such a way that we don't have that past anymore. Just think what that might be, what kind of world we might live in if we could alter the past at this moment in such a way that we all believed that what was the past was simply a figment of somebody's imagination by a flip of some kind of quantum computing switch. If you happen to be suffering from some really traumatic events in your childhood past, this could be a godsend. If you happen to be changing history so that you can make a lot more money in the present, this could be the worst possible invention we could ever come up with. Like all inventions of great portent, the good and evil on both sides have to be equally weighed. But it's possible.